Okay, tonight we're looking at 3.4 exponential and log derivatives. So if we sketch the graph of the derivative of f of x, it turns out that f of x is equal to e to the x, and f prime of x is equal to e to the x as well. And one of the things you can do is if you put y1 in, if you want to put in f of x, then you can put y2, and you know that you can hit math 8, so you would get then, you could put in a y1 and, the derivative. So you could really just say d dx with math 8, d dx, and then you could put in y1 and let the graph go. But remember, at the end, you're going to have to put x is equal to x. And you'll see that it produces the same graph because e to the x is like the superpower of all derivatives. It's its own derivative. So the derivative of e to the x is e to the x. And if we take the derivative with respect to x of e to the x, it's just e to the x. But remember, with e to the u, when we're taking the derivative with respect to x, it means that u has some kind of function of x in there that we're taking the derivative of. So we've got an e to the u, and then we would just multiply by du dx. Okay. So sometimes I like to go through the steps where I set this u aside. So you see we have an e to the u here. So we say u is equal to 2x minus 3x squared. So then du dx then is equal to 2 minus 6x. So what we're going to do is we're going to say f prime of x then is equal to our e to the u times du dx. And then we'll just plug things in. F prime of x is equal to e to the 2x minus 3x squared, and then we're going to multiply that by 6x. And not 6x. We're going to multiply by the quantity 2 minus 6x. And so then generally what we do is we move that quantity out in front of the exponential in 2 minus 6x, and then we multiply that by e to the 2x minus 3x squared. Okay, so there's our answer here. We can box that up. Okay. And then for the next one, we're going to say u is equal to our sine x. We have an e to the u form, and du is equal to cosine x, du dx, if you will. So we have an f prime of x, and that's equal to the e to the u times du dx form. And we have f prime is equal to then e to the u is equal to sine x. So we'll plug that in first, and then we'll multiply by cosine x. And again, even though they're both transcendental functions, we tend to put the cosine out front and then multiply. Somehow that it's very clear, if we have to use parentheses, we do. Want as much clarity as possible for ourselves and for others who are trying to read us. Okay, but usually I move that out front then, okay? All right, then we have this next rule. Now, I was going to spend some time proving this in class. I probably will, but I'm just going to go roll right through it now and just say what the rules are. So, no chain rule here. The derivative of a to the x is a to the x, but then there's going to be an ln of a you're multiplying by. So the derivative of a to the u form, so this is like functions like 2 to the x, 3 to the x, and not e to the x. So they're very similar. So this one is going to be a to the u, ln of a, the base is a, and then times du dx in the end. Okay, so if you look at this, we have y is equal to 3 to the 6x plus 4. So then we'll use y prime this time. Y prime is equal to 3 to the 6x. Now we could say u is equal to, we really have this form here. U is equal to 6x. So we need a du dx in this that's equal to 6. So we have the a to the u form times ln of a, which is going to be 3, so ln of 3. And then we have times du dx. Since the rule is right there, I'm not going to rewrite it again. So that's just going to be times 6. You have to be careful with this because sometimes people want to multiply the 3 times 6 and get 18. But we have y prime then is equal to, we could have 6 ln of 3 and then times e. But again, you want to watch out for this idea with the exponential cannot be multiplied. Oh, I have e. Why did I put an e in there? 3. I have 3 to the 6x then. So now what you can do, you could say 3 to the 6, but at that point, you're just dancing around, manipulating your expressions, having a great time, but it's not really doing anything for you. because you can move the 6 around to the 3 and make it ln of 3 to the 6th power, but who cares? All right. Now, then, see, some of this stuff you guys already know, so this should go pretty quickly. These last couple of rules I'm going to prove in class, so why are they like this, or what makes them like that? And we're going to actually use the E form of a to the x. So we have 3.4 exponents and logs, and now we have derivatives of logarithmic functions, which you guys already know, so you've kind of beat this to the punch because I've already taught this to you. So you have 1 over u times du dx over here, right? The derivative of ln of x, you know, is 1 over x. The derivative of ln of u, then if u is some other function of x, then is 1 over u times du dx. So in this case, we're going to say u is equal to cosine x squared. So it turns out you have a double, let me put parentheses on this, double chain rule with this. So probably won't be too hard for you guys now that you're really used to this. So we're going to then say du dx is equal to negative cosine. The derivative of cosine is negative sine x squared. Keep that variable the same. And then you're going to take the derivative then of x squared, which is 2x. So remember how you do that chain rule kind of thing. Kind of build a chain, if you will. Take a derivative of the inside function there. Okay, so what do we get? We get that's equal to negative 2x. Put the 2x in the front, and then we say sine x squared. Okay, so now when we do this, we have that, 1 over u du dx. I'm just going to write that here, times du dx here. So it turns out that is then f prime of x is equal to 1 over cosine x squared, 1 over cosine x squared, times, and we have negative 2x sine x squared, right? So in this, what's really cool about it, sometimes we get identities that do simplify, right? So we get f prime of x, and you guys know sine over cosine, so I'm going to kind of put it like this instead of doing another line here. I'm going to keep the negative 2x in the top, and then sine over cosine is tangent. So I'm going to write that as tangent x squared, and it simplifies our expression quite a bit. Okay, so for the next one, let me see. We've got our inside function is cube root of x. I'm going to write this as x to the 1/3 power. And then as I handle that, then I've got du dx is equal to 1/3 x to the 1/3 minus 3/3 is negative 2/3. And I could write that differently. I could write that then as 1 over 3x to the 2/3. And then I could write that as 1 over, if you wanted to, you could write that as 3 times the cube root of x squared. Okay, if you like to write it like that. Sometimes I like my answers to be somewhat parallel to my original problem. So let me see. So we have f prime of x then is equal to 1 over u times du dx. So we end up with 1 over the cube root of x, right? Cube root of x. It's sometimes interesting with the answers that you come up with, right? It's like 1 over the cube root of x, right? U is like that, x to the 1/3. And then times du dx, which is 1 over 3 times the cube root of x squared. So we get f prime of x is equal to, well, we can multiply these together. Let me move some things around. Moving the furniture around. And if I do put that up here, and you can kind of see from this one, this is, oh my golly, it's 3 times, it's in the bottom, it's 1 over 3 times, you have the cube root, and they're both cube roots, so I can move them together as x times x squared. Ooh, that's x cubed, so you know what the cube root of x cubed is. So we end up with 1 over 3 times x. Pretty cool, pretty nifty, right? 1 over 3x for our final answer. No cube root at all. Okay, so, and then one more, we have the derivatives of logs. Now, these are a little bit different, and again, I said that I was going to go through these with you in class, but I'll just give you the rule. It's 1 over ln of a. Sometimes I put a parenthesis around that, and it's then times 1 over x. So, I'm going to leave it like this. In this one, I have this one is u then, so it's 1 over ln of a times 1 over u times du dx. Okay, so in this one where you have the log base 4 here, now you have to understand with the log base 4, then you have f prime of x. If you wanted to, you could say, well, u is equal to 2x to the 5th, and then du dx is equal to then 10x to the 4th. So we're going to use that in here. So we get 1 over ln of 4, ln of a. And here, notice that the a is the base of the logarithm. So then it's 1 over ln of a times 1 over u. So that u is 2x to the 5th. And then we're going to multiply by du dx, which is, I'm sorry, I said 2x to the 5th in the denominator. Then that's going to be times 10x to the 4th. So let me draw a little line here, just to make sure they don't intersect. So we get f prime of x then, and you just have to be careful with the expressions. You want to simplify, of course. So you have 1 over, and I generally leave that ln of 4 in parentheses so it doesn't mix with anything. And then I've got this 10x to the 4th, and I've got a 2x to the 5th in the denominator, so I'm going to do a little simplifying here. So that's going to be a 5, and then in the bottom there's going to be an x, because the x to the 4th and the 5th, so it's going to be 5 over x, something like that. So when we write our answer, I'd probably write it like this. F prime of x is equal to, I put the 5 in the numerator. I did that kind of quickly. Hope that's, and then I put an x ln of 4 here. And then sometimes I don't have to worry about the parentheses around that, just making sure that that I'm very careful about how I'm presenting that both to myself, so I know what I'm doing, and for others that are going to be reading. Okay, for the last one, we have u is equal to 3x tan x. So that one we're going to have to use the product rule on that. So we have du dx is then equal to, it's going to turn out to be 3 tangent x, and then that's going to be 3 tangent x plus 3x secant squared x. Okay, so there's a derivative here. So we get f prime of x then is equal to 1 over 3x tan x. So there's your 1 over u. Oh, I'm sorry, I forgot the 1 over ln of 6 here, because that goes in there too. Let me move this down just a tad bit. So we have 1 over ln of 6 times, and then we have times 1 over u, and then we have to multiply by the derivative. So the derivative is 3 tan x plus 3x secant squared x. So now that's kind of the whole thing, but we can compress that a little bit so we have it in one expression, and we're just about finished here. So f prime of x is equal to, we would just write this as 3 tan x plus 3x secant squared x. We could, if we wanted to, we could write this all in terms of tangent if you wanted to, because secant squared is tangent squared plus 1. And then we have ln of 6 in parentheses, and that would be times 3x tan x. There, and there you have it. There you go. There it is. Okay, so that is the notes for today. And let me see, I think you have your practice problems that you want to do, and maybe we'll have some time in class tomorrow to get caught up with some of those things, and the test prep problems. But remember, e to the x, it's the superpower of all derivatives, because e to the x is its own derivative. And I will see you when I see you. Have a great day.